The TBS1000B instruments offer a built-in FFT that can help you see the frequency content in your signals. The fast Fourier transform is an algorithm used to transform time domain information into frequency domain information. You can use the FFT operation on an oscilloscope to view and measure repeating complex waves as sine wave components. For example, you can use the FFT for radio frequency analysis of radio transmitters, as well as for vibration analysis of mechanical devices. You can also use the FFT to analyze the distortion of a sine wave being generated by a circuit. We'll show how to use the FFT function using the oscilloscope's calibrator output. This signal is basically a square wave with frequency of 1 kilohertz, amplitude of 2.5 volts, and a DC offset of 2.5 volts. First, we'll get a stable waveform by using the autoset function and then set the vertical scale to use as much of the screen as possible. The FFT function can be quickly accessed using the FFT button on the front panel. Pressing the button opens the FFT screen and displays the FFT setup menu on the right. Let's pause here and take a quick tour of the display. Details about the waveform and the scale settings can be found on the bottom of the display. On the bottom left is the amplitude scale. It's given in decibels per division, so we can display a wide amplitude range. Next to it is a horizontal scale representing hertz per division. Next to that is the sample rate, shown as samples per second. The FFT window type follows. And the last number on the right represents the frequency of the currently triggered waveform. You'll need to verify that the trigger source is the same as the FFT source to see the frequency of the FFT source. When you use a scope to perform FFTs, you'll always have a non-integer number of cycles in memory. This will cause inaccuracy unless you deal with it. FFT windows help compensate for the partial cycles. Selecting a window depends on what type of measurements you plan to take. In this case, we'll use a flat top window. If you forget, don't worry. You can use the help system to get an overview of the FFT functions and to see details on which window function is best for your measurements. Similar to the time domain, you'll set the horizontal frequency scale so you can take measurements, but that's where the similarity ends. In the frequency domain, frequency resolution improves as you turn the horizontal scale counterclockwise. This is completely opposite to the way things work in the time domain and can take some getting used to. As you adjust the frequency scale, keep an eye on the sample rate to avoid undersampling. You need to make sure you keep the sample rate high enough so that you're sampling at twice the highest harmonic you want to see. In this example, we'll set the frequency scale to 5 kilohertz per division, which corresponds to 100 kilosamples per second. The Nyquist theory says that for a sample rate of 100 kilosamples per second, we can discern frequencies up to 50 kilohertz. The FFT zoom control spreads the horizontal scale out without changing the sample rate. This simply makes it easier to see the frequency components. For this example, we'll set the zoom factor to x5. Finally, we usually want to look at the fundamental frequency and lower harmonics. Use the horizontal position knob to shift the spectrum to the right. The displayed FFT figure shows the DC offset component, the fundamental frequency, odd harmonics, and even harmonics of the square wave. Cursors provide an easy way to pick off information from the spectrum. We can clearly see the odd harmonics, and we can measure their amplitude too. For example, we can confirm that the fifth harmonic occurs at 5 kilohertz and observe that it has an amplitude of about -7 dBV, or about 400 millivolts RMS. Turning on the source waveform option will open a window that shows the waveform in the time domain. This dual window display mode simultaneously shows the frequency and time domain representation of your signal. This can be useful when evaluating the frequency effects of changes made in the time domain. Now you know how to set up an FFT and extract information from the spectrum. Go ahead and experiment, After some practice, you'll develop intuition about the time and frequency domains.
Find out more at Vicom's website.